So I think we have a final talk now, which is on the new swimmer. Is that all right? Yeah, yeah. Update on VFDs and swimmer, mirror and onion. So a lot of stuff there. John Mainzer and Brian Sawicki.
Yeah, let me set up to share here. Let's see if we can get this right. Let's see. And get this to full screen. Okay, can everybody see that well?
Yes, looks good.
Okay, so I'm John Mainzer, Principal Architect over the HDF group. I'm going to give you a very quick overview of some of the new VFDs we've been working on, and also VFD SWMR, which is a reimplementation of the SWMR capability. We'll start with splitter and mirror. The objective here is to duplicate an HDF5 file on a remote system as you were writing it on a local system. Did this with two VFDs. The splitter, which does pretty much what you'd expect it to do. It takes an incoming stream of IO requests, relays the full stream down to its read-write channel, and the writes requests out to a write-only channel. You can use that locally to make a duplicate. In fact, that's how we tested. But for this particular case, you would want to stack it on top of the Mirror VFD. The Mirror VFD is, in essence, a write-only network VFD. And what it does on open is set up a connection and a writer process on the remote system. Then all of your write requests are passed to the remote system and written directly. And then on close, we shut down the writer and the close the file, of course. So this is now implemented. It's available 1.10.7 and 1.12.1 when that comes out. It is socket-based. We're mostly putting together proof of concept, so we have not optimized it in any particular way. At present, there's a factor of 6 slowdown in the typical case. And that's about what I have on that one. So unless there are any quick conceptual questions, I'll go on to Onion. Okay, going on to Onion.
I had just a question, is that the slowdown is only for the mirrored file, it's not for the...
Well, it's actually both splitter and mirror.
Oh, okay.
Because the splitter, again, was not done to be particularly efficient. It quite literally sends the IO request down the read-write channel. That comes back, and then it sends it out to the write-only channel. So you're going to get a slowdown there as well.
Okay. Okay.
So obviously, there are all kinds of optimizations we could make, but we wanted to get the proof of concept up and running. For those who don't have huge performance requirements, it should work just fine. And we'll see how much demand there is for a more efficient version. So going on to Onion. Here, the objective was to support a coarse version control and provenance management in HDF5 files. I say coarse because we're collecting versions only as of file close. At present, we're annotating each version with date, ID of user, optional comment. We could put other things in as well if we wanted to. This, again, is implemented purely at the VFD layer, which makes it transparent to the HDF5 library. It functions by breaking the logical HDF5 file into pages. When a page is first modified after file open, the VFD does a copy on write and then applies further changes to the copy. And then for each version of the file, effectively we maintain an index for that version, mapping logical page in the HDF5 file to the appropriate physical page. I'd hoped to have a demo for this for you today. Unfortunately, the gentleman who was working on it ran into a little bit of difficulties. That said, we have that minimal implementation. When it gets released is to be determined. In case my verbal description was a little bit confusing, I have a quick example of what might happen with Onion VFD. Suppose we have version 0, which will typically just be written normally. And we open it with the Onion VFD, creating version 1, which, let's say, modifies the first page and adds page 4. If you'll go over to the right-hand side of the slide, you can see how we have now an index mapping logical page 0 to a physical page 4, and the new logical page 4 to physical page 5. Going to version 2, we just modified 2 pages, and you can see how the logical pages are now being mapped to different physical pages in the file. So that's the basic concept there. Again, if there are quick conceptual questions, now is a good time. Otherwise, I'll go on to VFD SWMR.
Are there any questions? I mean, I had one already, which was, would this help against files being corrupted?
Yes. The way we've implemented it right now is all of the modifications and the indices are kept in a separate file. So you actually never modify the base file. There are several possible ways this could be implemented. We could keep the indices in the same file as the original version, but the separate files seem to be most appropriate for right now.
There's a question from Graham as well saying, does this mean we need to defrag the files in the future?
Here, let's take the one separate file case. In that case, yes, the physical pages are just going to be placed at the end of the file as we need them. And so there'd be a lot of bouncing around. And there are the obvious performance implications there. I'm not sure that defragging is really appropriate if you wanted a particular version and you were concerned about efficient access for that particular version. It might make more sense just to copy it out and make a straight copy of that version. I hope I've addressed the question there.
I think so, yeah. Okay, I don't see any other questions. Yep, we can go on.
Okay. SWMR redesign and reimplementation. For those who aren't familiar, which should be nobody at this point, the objective is to allow one or more reader processes to read an HDF5 file as it's being written. We have an implementation. It works. Some limitations. You can't create groups, for example, while you're in SWMR mode. It also is much less modular than I would like. So my objectives in the redesign and reimplementation, first and foremost, was to improve modularity and maintainability. And as architect, that's the big one for me. Another objective was full SWMR, by which I mean allowing the use of all HDF5 API calls while in SWMR mode. Third one was supporting a maximum time from write to visibility to readers. And that's another area where the existing implementation has problems, as you can't get at raw data unless you can see the associated metadata. And unless you do a flush manually, the metadata is going to be pushed out of the metadata cache only when the cache is full. So that means, in general, if you need to see that raw data fairly quickly, you wind up having to do a bunch of flushes. Another objective was to be able to support non-POSIX file systems. NFS initially, but there's no reason why this can't be applied to object stores as well. To do that, of course, we're going to have to get some virtual file drivers which support object stores directly. That will happen eventually. We haven't done it so far, mostly because of the way our raw data I/O pathways are constructed, which make it very difficult to do an efficient object store-based VFD. However, the necessary changes in the HDF5 library architecture to support that are in progress. A final objective is to support SWMR in parallel, which VFD SWMR will allow us to do. So to start to see what's going on, I'm going to give you a conceptual overview. And before we start, I'm going to say this overview is quite oversimplified. It'll give you the basic idea. If we have time, I'll go into some of the details, but I do want to save a little bit of time for questions and for some quick demos. So at this level, cycle of operation is really simple. The writer takes a snapshot of the metadata once a tick and writes that snapshot to an auxiliary metadata file. The reader uses a specialized VFD to intercept metadata read requests and satisfy them from the snapshot. Obviously, the reader has to check for a new snapshot every tick. To keep the metadata file from exploding, we have the snapshots expire after max lag ticks. And assuming the file system can keep up, this arrangement means that metadata, and therefore raw data, assuming it's getting out that fast, is going to be visible to the reader within 3 ticks. Now you notice I've been using this term tick. It is a configurable value, as is max lag. For our testing, we typically use 300 or 400 milliseconds for our tick length, and max lag is typically in the order of 7 ticks. So here again is an oversimplified diagram of what's going on. The writer process, which is on the left, is keeping track of time, and every tick, it will take a snapshot of the metadata, write it to the metadata file. Raw data ideally would just dribble out as it normally would. However, to make our testing easy, for right now, we are flushing raw data at the end of each tick. As I'll go into later, we're in the process of releasing that constraint, but we're going to have to modify our test code to support that. On the reader side, when a metadata read request gets down to the VFD layer, the VFD SWMR reader VFD intercepts it, satisfies that request from the metadata file. If it's a raw data request, it goes down to the underlying VFD, typically sec2, and that gets read directly from the HDF5 file. So before I go on, at a basic conceptual level, any quick questions? So either crystal clear or clear as mud. All right, I'll go on.
Actually, we did have a question from Walton. Can we get a list of all things?
A quick one. So can we get a list of all the things that a writer cannot do compared to a vanilla writer?
I'll get to that shortly.
Okay, perfect.
Bottom line is it can do almost everything.
Okay, because you said not creating groups or something?
Oh, in the existing SWMR, you can't create groups.
Okay.
VFD SWMR, you can. Okay. And write attributes and all kinds of other things.
Okay, okay.
Okay.
Perfect. Yep.
Now, design implications.
And there was a question from Peter saying, will this be transparent to the readers? Yeah.
I'm not quite sure I understand.
Yeah, I think what he means is that if there's features that are missing in the SWMR, VFD SWMR, is this transparent to the readers?
For VFD SWMR, yeah. If you use a feature that we don't support very well in VFD SWMR, either the writer won't be using it or the underlying data will already be in the file. In either case, it should work.
Okay.
But as you can see, it's not a very long list.
Okay. Good. I think
as I was saying, most elements in HDF5 just work, yielding, as I said, almost full SWMR. The major exceptions: variable length raw data. Unfortunately, due to the way we implemented variable length data in HDF5, where the variable length data is actually stored as metadata that just does not like VFD SWMR. We could probably get it to work under some specialized circumstances, but I would stay away from it until we get around to doing a re-implementation of variable length data, which we should do anyway, as by putting the variable length raw data in the metadata cache, we are blowing out the cache and you're running into some pretty severe performance constraints. If you have a very long running API call, that can overrun max lag ticks. So if you're using VFD SWMR, particularly on the reader side, you would want to avoid that. The final one involves older versions of the file format. And the problem here is if you do extreme things with the older versions of the file format, you can create arbitrarily large pieces of metadata. And by arbitrarily large, I mean tens of megabytes. This, of course, is going to blow up the size of the metadata file, since we might be writing that particular piece of metadata to the metadata file every tick. And thus, as a general rule, you should use only the latest file format with VFD SWMR. Can you get away with the earlier versions? Yes, if you're not doing anything particularly extreme. And indeed, we test it that way. But I would encourage everyone to stay with the latest file format. And the bottom bullet here is, of course, my hobby horse. Upper levels of the library can just ignore SWMR, which reduces maintenance cost on the HDF group and means for the user, if you don't use SWMR, you don't have to pay the overhead. Some more implications. The snapshots don't require POSIX semantics, and that's why VFD SWMR for NFS is possible. We haven't implemented it yet, but it's not terribly difficult, so hopefully pretty soon. Ditto for object stores. Snapshot design can also work in parallel. However, VFD SWMR requires a page buffer, which is not implemented in parallel right now. We have two pretty strong use cases for parallel page buffer, so I think that's happening soon, but it may not happen by our first production release. VFD SWMR on remote systems using Mirror and Splitter is possible. It's not implemented yet. It's a simple configuration issue for the HDF5 file proper. We need to add some glue code in to let the metadata file write use the VFD interface as opposed to doing its writes directly. Once that's done, we should make it work. Incidentally, you can already use Splitter and Mirror with the existing SWMR implementations. With minor tweaks, the snapshot design can support coarse metadata journaling for crash recovery. Not sure when we're going to do that. Sort of depends on how much interest there is, but I throw that one out as a point for anybody who's interested in to speak up about. And again, to my favorite hobby horse, new HDF5 features should just work with VFD SWMR with little or no development effort. So, current status. There's an alpha release out right now. New alpha release should be showing up shortly. In the current alpha release, I think we're only doing Unix and Linux. Mac OS should be in the next alpha release. Windows is definitely on the to-do. Should be out certainly by the first production release. We only support serial and POSIX right now. NFS shortly, we hope. Right now, we are hard coding VFD SWMR to do flushes of raw data at the end of each tick. We're in the process of making this configurable to maximize throughput. It's really more of a testing problem than anything else, although it does open a couple of other interesting issues. If you need to do it, you would want to avoid things like references and such. We've started on performance testing, no particular attempts at optimization. I'll be showing you some initial results, but the bottom line is you're going to get your best performance with a small number of data sets, at most one extensible dimension. Group creation overhead is negligible, and file close can be slow. To understand that, I'll have to talk about one of the oversimplifications I made. We'll see if we have time. Objective is to have first production version by the end of the year. So going on to a couple sets of performance results. This, I think, one is pretty realistic. We're writing n by 1,000 by 1,000 data sets with 1 by 1,000 by 1,000 chunk size. On each cycle, we're extending each data set and writing an additional frame. Right now, we're using a 4 kilobyte page size and a 4 megabyte page buffer. I mentioned that as that's going to be a pretty important field to consider when you're tuning. And of course, at present, raw data is flushed at the end of each tick. Now you'll notice at 10 data sets, we're actually getting a speed up with VFD SWMR. That's perhaps hard to understand until you consider that by using VFD SWMR, we're reducing the number of metadata writes to the HDF5 file proper. And those writes are going to be done in pages. So I suspect that's where that's a little bit of a speed up is coming from. Once you get up to 100 data sets, we are probably exceeding the size of the page buffer and starting to see a bit of a slowdown. This next performance result, I somewhat hesitate to show people as it's intentionally inefficient and you would never want to do this. But we did this test to work or to beat on the weak part of this design, which is of course the snapshots. The more data that has to be written out in each snapshot, the more overhead there is. And you can see how by increasing the number of data sets, the overhead can become significant. So in this one, we're using 1 by 16 by 16 data sets of 1 by 16 by 16 chunks, pardon me, n by 16 by 16 data sets. And everything else is the same as the previous one. With only 100 data sets or 1,000 data sets, you'll notice the overhead is quite reasonable. We get up to 2,000. Probably we're starting to overrun the size of metadata cache and or page buffer. We're starting to see some significant overhead, and we get out to 10,000. The overhead probably in writing the metadata file is becoming quite significant. One last benchmark before I show you a couple of quick demos. Here we're just creating various numbers of groups in the root group, ranging from 1,000 to a million. As you can see, the overhead's pretty reasonable. I certainly hope nobody's going to have a reason to write a million groups in the root group or hopefully anywhere else. So, quick conceptual questions before I go on to a couple quick demos. Okay.
Well, there was one bravo from Herb. Bravo sounds very useful, especially crash recovery.
Yes, certainly doable. Now, excuse me, this is arguing with me. I need to get out of full page mode. Well, let's see if I can just quit out of that. Okay, good. So this first demo is just going to show you creating and deleting groups. So the create routine is going to create and delete a bunch of groups and data sets. And on this size, we're going to use a modified version of H5LS, which is just going to pull the file. So we'll start that one, and we'll start that one. And you can see how different groups are being created and deleted. This is pretty much like watching paint dry, so I'm just going to Control-C out of this one. Just good to show you that we can do it. This next one is a pretty bit of eye candy, frankly. One of our developers did this really almost a year, maybe more ago. And we'll get that going for you. Oops. Okay, come on. Excuse me. There we go. Excuse me. There. As you can see, the writer is generating data, and then it's being graphically displayed by the reader. If you want, I can go over to another pane and show you how the size of the file is slowly increasing. But
what is the size of this? Is that what is the size of the frame?
I didn't write this one, so I'm going to guess it's maybe 100 by 100. It's a toy size problem.
Yeah. Okay. No, I just
yeah,
it's very pretty. Yeah.
Yes, as I said, some lovely eye candy that Dave created. So let me Control-C out of this, and I'll see if I can bring my slides back up. Okay, so at this point, we have about 4 minutes. Questions, comments, observations?
I open the floor. I think the ones that were on, there was, Peter had a question, just that if you can ignore SWMR as well, if it's been written by SWMR.
Oh, yes. One of the neat things about the snapshot approach is there's no change to the HDF5 file. So the HDF5 file that's being written by the VFD SWMR writer is just a normal HDF5 file. And when you close it, it's just a straight HDF5 file. You don't have to do anything.
Just for my own understanding, you probably said it, but I didn't catch it. Was snapshots are in a separate file, or where are they?
They're in a separate file, and we have a few moments, so I'll go into it. The snapshot design has this problem of generating too much data. So what we try and do on these snapshots is include only the data that's changed in each snapshot. And the problem with that is that means that the reader will not always go to the metadata file. It may go and read metadata from the HDF5 file, which in turn means that we may have to delay writing metadata to the HDF5 file so that the reader doesn't get a message from the future. And that's the reason why file close on the writer side may take several seconds. It's really whatever you set max lag to.
Okay. At least from how large is a metadata file from John Wright? Does it typically fit in memory?
That depends on what you're doing. In some of our torture tests, we have managed to get metadata files up to 1 gigabyte. And in fact, that is the most recent bug that we're chasing. That was only with the old file format. Typically, they're going to be 1 meg or so. And if you can, you're really concerned about performance, put them in a RAM disk. As the metadata file just gets thrown away once the writer and all the readers have exited.
But it sounds very good. It sounds like it would solve John's problem, which we have today with very long scans and not being able to read the file always. Yeah.
Well,
I have Zenik.
Sure, go on.
Zenik said, what happens when the writer crashes, file not closed properly? Can the file get somehow damaged?
Yes. You have the same problem with the VFD SWMR writer as you have with any other HDF5 file writer. If the metadata doesn't make it out, the file will be unreadable. Now, remember what I said about the possibility of doing some course crash recovery using the snapshots? If there were interest, I suspect we could integrate that into VFD SWMR. So you would have both the SWMR capability and the course metadata journaling capability.
But there's something I mean, you would have to then do a manual, the system would have to do a manual restore or fix, yeah?
Yes, basically you would walk the snapshots and apply them.
Yeah.
There's some slight work that we have to do to see to it that file space that is allocated for metadata is never reallocated to raw data and vice versa. That's the tweak that I was talking about. But once you have that, as long as you're willing to keep all the snapshots, yeah, you can recover.
Well, sounds yeah, it sounds like a big improvement.
Thank you. We've put a fair bit of work into it.
I think we got the sessions up. Are there any anyone else wants to make a comment or question to John? Or I think how are we doing? Yeah, we're already at 6 o'clock. Yeah. I don't know. It's probably is there time for some? I think you've shown everything, unless we go into details. But maybe we should open the discussion. Elena, what do you think?
Yeah, I think we should open discussion. I have just one slide to show without plans, and we can start.
There is one question still for John. Will it be available for Java? I don't know.
So it should. I have to admit, I don't think about Java too much. Sorry about that. But really, to get VFD SWMR set up, it's a few new file creation and file access property list entries, and that's it. So I would expect so without much effort.
Okay, from performance, and someone, Castro Rodrigo, from performance point of view compared with current SWMR, has any significant difference in case of small writes and reads? Are they,
The answer on that one is, I don't know. I have been concerned with looking at the difference between no SWMR and VFD SWMR. I get this question from time to time. Without telling tales out of school, I can say that certainly on group creation, VFD SWMR is a lot faster than an attempt at full SWMR, which was done elsewhere. So I think VFD SWMR is going to be the one that wins, and will replace the existing SWMR. But no, I haven't checked. And part of that is it's sort of hard to compare, because with existing SWMR, if you want the data out, you have to do those flushes to get that metadata written out. So we'll probably do that at some point, but from my perspective, if I can get performance overhead in the typical use cases down to under 10%, I think we probably have a winner.
Yeah,
if somebody thinks otherwise, please tell me.
No, I don't. I mean, it just seems like it's winning on. It's an improvement on all sides. So, from my point of view, I don't see. But I'm not someone like my developers who are working on this on a daily basis. Thank you very much, John. Very, very interesting. Yeah.
Quite welcome, and thank you.
Yeah, thanks.